My name is Daniel Butterworth. Feel free to call me Nate. I've been at Google for a couple months now, and prior to this, I was at the University of Sydney, and so I was working on all the kinds of problems that you might face as a researcher, and hopefully some of the Python tools and techniques that we'll go through today will help you overcome some of those problems. So we'll demo a few different scenarios. So I've got a couple people from the G2G AI for Science organizers on the call. So Scott, Leafy, Canal are all here as well. So look out for them in the chat. If you have any issues throughout the time, feel free to interrupt. We can make this sort of as interactive as people want to be. If you are comfortable, leave your camera off and ask questions as you go, but feel free also just to sort of listen passively in the background as well, and hopefully some of these things will go into your subconscious, but I think we get more out of it if we're more interactive. As I said, yeah, feel free to interrupt, unmute yourself, or just post something in the chat as we go. We'll take sort of plenty of breaks throughout the day. I think we'll aim for sort of on the hour, each hour to have at least a few minutes and maybe a longer break in the just before the last hour. Because yeah, 4 hours on a virtual call can be quite tedious. So make sure we get up and move our legs from time to time. We'll ramp up the exercises as we go. We're going to start with some fundamental sort of Python knowledge, and hopefully this will sort of equip you with the baseline, so you can go to the next level with solving whatever research problems that you may have, or then asking Gemini the right questions to code on your behalf. We want to sort of get you to that point, and so you have a good idea of sort of how these AI tools might be working under the hood, so they're not so much black boxes. Alrighty, so let's go. I'll post the link to the notes in the chat. I think everyone would have got them who completed the pre-workshop sort of survey, which was most people. So that is the notes I've just put in the chat. If you don't have a link there, I'm going to be loosely following these. The structure will be about the same, but we'll be coding from a brand new blank slate. Everyone can access that. Is there anyone that can't access the notes at this point? Speak now. Good stuff. Fantastic. Yeah, so if you've never used Google Colab environment before, this is sort of what it looks like. It's what's known as a Python notebook, and it's a series of kind of like interconnected cells where some are snippets of code and some are just free text or what's called markdown language, which makes the text, you can format it slightly, you can embed some HTML there as well. But the idea is that there's sort of like a Python engine running in the background, or what's known as a runtime, and that's sort of serving us Python for us. You can install sort of these things locally on your own computer. It's just a bit easier using the Google Colab environment. There's a bunch of sort of AI embedded sort of features, so you can ask questions as you go of the AI, and it has the context of your whole notebook there as well, so it can help you code on your behalf. I'll sort of touch on those occasionally, but we'll focus sort of mainly on the Python side of things. But yeah, if you have any questions about this, feel free to ask as we go. So to begin with, what I'm going to do is click File and click New Notebook. That's your first task for the day. I'm going to start with a completely blank notebook. Hopefully that should work. Fantastic, and it's sitting here blinking, waiting for us to write some code. And the very first piece that we can type in. So all of today is going to be interactive. You typing commands in. I'll try to. There'll be very minimal copying and pasting from the notes, unless you sort of get stuck or something. But you shouldn't. Every bit is kind of self-contained. Okay, so the very first command I'm going to get you to type is print, and open a parenthesis. And you can type hello world. And then there's a few ways to execute. So this is just the Python syntax for printing something to the screen. There's a few ways to execute this. You can click the play button, and that should, you can see up there that it's now connecting to a Python runtime. So it's finding some free CPUs off in the Google Cloud somewhere, and it's then connected it, and now it's distributed it to you to use. And now you can see that our command here has been executed, and it's printed out below hello world. So yeah, you can press that play button. You can press Shift Enter as well, or Control Enter, I think, does it too. And if you're on a Mac, I think Command Enter is the equivalent. And yeah, there's a couple ways to sort of run that cell, but yeah, we'll see how we go with that. Okay, so that's a print statement, and we'll unpack this sort of more as we go. To begin with, let's talk about some real basic structures or object types in Python, and these are called, the first one we'll talk about variables. And a variable is basically an object that contains some kind of information. So we can start with something like project name equals, and then this is called a string, where we do quotation marks, and you can call it, my project, and press enter, and nothing happens when I ran that cell. You can see nothing happens, but if I wanted to then print out that project name, and I run that, it will print it back out for you. And now a good feature of notebooks, in particular Python notebooks and Colab, is that you don't even have to type the print statement. You can just type project name, and it sort of prints it out in a sort of different format. And that's just like a shortcut, I guess, for displaying information inside a variable. Okay, so this is holding what's called a string variable. How are we doing so far? Am I getting ahead of myself yet? Good stuff. Okay, fantastic. Okay, so yeah, this is called a string variable, and we can store any kind of information in a Python variable. We can do number of samples. Make sure you don't make typos. Equals 22, and then this is called an integer. You can do something like type number of samples. I just auto completed that, so Google Colab said, hey, are you trying to type in this variable? So I pressed tab, and that was a little shortcut, and it tells me this is an integer. And if I do type of project name and run that, it says it's a string. So these are different types of variables. You can have floats as well. So ph equals 7.4. So that's a floating point number, where yeah, it's basically a decimal. And there's these other sort of more computational type variables. This one's called a boolean variable. So results equals, you have true. Results equals true. And yeah, so that one is a boolean, which is either true or false. So that can come in very handy in a lot of situations. Okay, cool. So that's like, there's a bunch of other types, and we'll sort of come across them as we go. But that's the real fundamentals of it. And yeah, we'll keep working through. This is true for any programming language. So there's sort of different rules and constructs and syntax that you kind of learn. But most of them have types and different ways to assign a variable to a particular name. And then we can start doing fun things with it. So remember that, like most coding languages, and Python's no exception, they're basically big calculators. So we can do some arithmetic with our variables. So number of samples, you can type it out, or make sure you spell it right. +1. and that will be 23. We can even new result equals number of samples, make sure it's lowercase, plus 10. And then, do we know what new result will now equal? There's a few ways we can display it. We can either type it out or type print, new result. And there we go. So that's 32. We can go back up and modify this later on. So let's go 15. And then new result will get updated to 37. So you can do obviously subtraction, division, sort of whatever you need to do. That turns it into a floating point number. There's a couple of other funny arithmetic operators. So like there's modulo, which is the division and remainder. So this so 5 goes into number of samples. Wait, is that right? I can't remember. How does modulo work? Anyway, so it's the remainder of a division. So yeah, 23 divided by 5 with 2 left over. That doesn't quite make sense. Anyway, so there's different arithmetic operators and some other things that will come up as well. So there's comparison operators. So if we have something like, let's go a new result equals number of samples. So this equals, this is called equal to, and it, rather than assigning a value to new result, it actually just compares these two numbers. And so this should result in false, because new result, I think, equals 2, and number of samples equals 24. And so, sorry, number of samples equals 22. So that's why my modulo was like that. Okay, so this is a comparative sort of test. So it tests either side to see if that equals true or false. So you could have equivalently 1 equals 1. That should be true. Sorry, or 1 equals 2, and that is false. And you can do 1. Is that greater than 2? And these are sort of logical tests. So 1 is not greater than 2, so the answer is false. Is 1 less than 2? Yes, that is true. Is 1 less than or equal to 2? That is true. Is 1 less than or equal to 1? Yes, that is true. Is 1 less than 1? That is false. So there's all these sort of different combinations that you can use to validate, does a number on the left-hand side somehow relate to the number on the right-hand side of the operator? Okay. And yeah, we'll see more of these as we go. Okay, any questions about these so far? Good stuff. Yeah, we're getting through the sort of the basics of things. Okay, so we can we can do all of that with different variables, and we can assign things. So just comparing the notes here. So you can do, let's do result. Let's go result 1 equals 2. Result 2 equals 57. And let's do that. Oh yeah, so I've been typing sort of individual bits of code in a single line, but you can type multiple pieces of code in the one cell. That's just more for demonstration purposes and just so it prints out. But here we'll type a few things in here. And so now you can assign a variable saying, let's test variable is equal to result 1 less than result 2, and then we can add something down the bottom, print test variable. So result 1 is 2, result 2 is 57, and we want to test this out and see if result 1 is less than result 2. What's it going to be? I think it's going to equate to true. It prints out true. And you can imagine how you can make this sort of more and more complicated as you expand it out. Now, I might just for fun, you can mix some data types. So if I did like 2.5, that's a float comparing with a integer. I think that should work. But if I did 2.5 and ran that, oh, here we go, our first error. So it says type less than, not supported between instances of string and integer. Now, understanding errors and sort of interpreting what they mean, like that looks quite formidable. Up here, it says like type error, traceback, like this is all confusing. The most interesting part of the error is usually at the very end, where it tells you sort of like what happened. And here, if knowing what we know, we can interpret this to mean that your numbers, one's a string and one's an integer, and like it doesn't know how to compare those two, so it just fails, which makes sense. So that may have been a mistake or something, so we can fix that up and run it out again. And actually, I might just do, let's say like result 1 is a good value, and result 2 is a different value. Will this one work? I think, yeah, so that is comparing it. I don't know when that would be the case if you'd use a less than operator, but using something like an equals operator here might make sense if you're comparing two different strings and wanted to see if they were the same string. So if you're like reading documents and had to compare like a patient name and a patient name in like a different set of documents and wanted to make sure that they were the same. So that's false, but if this was a good value, it should be true. There we go. And already you can see the powerful nature of sort of reusable code here in Python by I'm just sort of adjusting things slightly in here, but running it again and again and again. So it's very easy to sort of run things sort of multiple times, slightly tweaking things and getting an answer very, very fast. Okay, so next up, let's introduce something called Python lists. Oh, I haven't spoken about comments yet. Let's so this is a comment. Is a comment. It is for humans to read. Python ignores it. So this thing with the hash at the start of a line, this is what's called a comment. If I run that, like nothing happens. If you see long code blocks, you'll often see a comment there written by a human who says like, oh yeah, this function does this, and I chose it because of these reasons. So it's a really good way to write notes to yourself and to people in the future who are going to read your code. So write comments early and often. You'll see them around. Again, in other programming languages, the concept of comments exists as well. And so what I'm going to do is introduce now something called a list. So let's go. My list equals, and Gemini here, or Colab, is suggesting some ideas to put in my list, but I will ignore that and I'll put in my own numbers: 52, 23, 11. And so a list is just like a container of items. In this case, I'm using integers. You can have sort of mixed types in there. You can have strings. You can have integers. You can have floats. In fact, I'll add a float. I'll add a string as well. A string and 0. All right, so that worked. So I can print the list. And I can explore the list as well. So I can do or what's called indexing or yeah, using the index of the list or slicing the list. So if I do my list 0, so Python counts from 0. So item number 0 is 52. And so that means item number 1 should be 23. Item number 0, 1, 2, 3, 4 should be the string there, string. And if you've got a really long list, you can actually count backwards. So I can do -1 to get that 0 out. If I do item number 6, I'll get an error and say list index is out of range. So my list is only 5 long, or is it 4 long? 5 long, a length of 5. In fact, we can determine that. So len my list. So that's a built. This is called a built-in function, kind of like the print statement. Len is a Python built-in function that that shows us the length of an object. You can do the length of strings, and I think you do the length of numbers as well, but it should just be 1. Oh yeah, so the length is 6, but because it counts from 0, so 0, 1, 2, 3, 4, 5. 5 plus 0 is 6. Yep. Yeah, details. So some programming languages, they start from 1, so that can be confusing if you go between like MATLAB and Python. Okay, what else is interesting? Oh yeah, you can slice a list by doing my list. Let's say index number 2 to 5, and so that will print out from item 2 inclusive up until 5. So it's index 2, 3, and 4. Good stuff. Okay, cool. And yeah, you can index also like up to the end with a -1. So good stuff. Yeah, lists are amazing. You'll use them all the time. Okay, cool. So that was module 1. That was super easy. I was hoping to fly through that. Sorry, we should never say easy. That was the fundamentals. So I was hoping to get through that okay. Any questions in the chat? Thanks, Scott, for resharing those notes. Good stuff. Okay, so now looking, I'm just jumping back to the notes. So yeah, we're up to module 2 here, and now we're going to get into some, I guess, yeah, we'll keep ramping things up, and we'll start looking at conditions and control flow statements. Okay, so programming languages like Python, you always talk about the logic of them, and so there's sort of natural language where you describe a problem. You know, if I want to make some toast in the morning, you know, first I have to get the bread out of the fridge or something. You know, there's sort of conditions that you face, and so that's kind of how you have to give Python instructions. So let's introduce something called an if-else statement. And basically that is, let's set a value to begin with. I'll follow the notes here. P value equals 0.065. And I'll say if P underscore value is less than 1, print yes. Okay, so if I run that, it's true. Yes, fantastic. So we're reintroducing these conditional operators here. Now, if I wanted to say if it's greater than 1, which doesn't make sense for p-values, but that's okay. So nothing happened. So that's fine. Because it's kind of what we expect. The condition is not met. So it says is this true? The statement actually equates to false, because that's just a true false sort of operator there, and it won't print. I'll put it back to less than, let's go less than 0.05. Oops, that's a typo. I'll run that again. Okay, wait, and so nothing happens, that's fine. Now, so then what you can have, so again, Colab Gemini is giving me some suggestions here, but I will say else, oops, if, else, print, no. All right, so it said no, that's not true. And what you can see here, I think it even automatically did it. It put some indentation there. So this is required by the Python programming language, that when you have a new line with some sort of flow statement, it requires indentation to know that it's part of that like code block. Otherwise, if I remove this, will this work? I think it'll say indentation error, expected an indented block after the if statement. So that's pretty clear on line 3. So there we go. On line 3, it expected an indentation there. So that's really important. That'll catch you out in a few places, and it can be really. Sometimes you might make a mistake where where there's no error, and and something is being calculated sort of like outside the if statement instead of inside it, and that can throw you. So that's important to pick up. Other languages have sort of different rules around this, but it's just a sort of a style and syntax of Python that you use indentation, and it makes your code sort of more readable, I think, compared to sort of in MATLAB. You don't need any of that. You can just write a whole block, and there's sort of no visual feedback for where like one thing starts and the next thing ends. But a lot of people do indentation anyway, and give a lot of white space in things like C and MATLAB, just because it looks better. Okay, so sorry, let's continue this. So if else, so that's one thing. You can also have like several conditions, and we have these in what's called an elif. So I'm going to put that in the middle there, called elif. So here's like another, so I can do p-value less than 0.1. And yeah, I'll just print maybe there. Why not? So I can run this, and there we go. So is it less than 0.5? It's not. Is it less than 0.1? Yes, it is. So let's do maybe. And so it never reached that last final else statement there. Okay, any questions about if and else? We'll see those again later. All right, so I'll introduce a concept now called a for loop. So there's different, one of the benefits of Python that I mentioned earlier is that you can do something like 1 million times. There's no sort of extra effort between doing it twice and doing it 1 million times. And the way you do that often is via things called a loop. And the two sort of main ones are a for loop and a while loop. Are there other ones? Maybe. Yeah, I think there's try and except. There's different conditional state loops and ways to repeat the same code again and again. And so a for loop, basically you say for, let's say a value in my list that we had before, print all the a value. And look at this, back up at my list that I had here, my list 52, 23, 11, 5.2. It goes through one by one and it prints each of those things. And I can put in a whole bunch of different logic in here. I can do print hello, and each time it's going to print hello, then 52, then hello, then 23. So it's looping through one by one, again and again, until it's gone through all the values in the list there. And you can do other things as well. So you can sort of, if you don't have a list to go through, you might just want to go through the numbers like 1 to 10 or something. So for time point in, you can use a function called range, and you say range from 1 to 10, and you can see it popping up, and it gives me some sort of indication for what it gives me a snippet of the documentation for how this works, which can be helpful. Okay, print time point. So that should just be 1, 2, 3, 4, 5, 6, 7, 8, and I think 9. It'll stop there, so it doesn't quite get to 10. So it's inclusive of the first one, but not inclusive of the second one. And so what else is interesting here? When we look at what's this value here, we're actually like coming up with a sort of a temporary variable. So this variable only exists within the loop, and then each time you go through the loop, the variable gets reassigned to something else. And I should just point out, I've been using some underscores. There's different rules for the syntax for what you name variables. So something like variable underscore 1, that's fine. Variable 1 equals, even the spacing between the equals and the 1, that's not enforced, but there are style guides and there are sort of preferences for doing that. You could do, can you have this though, variable equals 1? And no, you cannot. So you can't start a variable name with a numeric, with a number. It has to be letters, or you can also have underscores. I think that's kind of it for what you can have in a variable. Like any other special characters won't be allowed. Yeah, so all the other special characters, I think, like not allowed, but underscores and numbers and letters, but it can't start with a number. So there you go. There's some rules that you may come up with up against once, every now and again. And okay, so okay, let's do. I'll go back to the notes for this. Let's go gene names equals TP53. So making a couple of string variables, BCRA1, EGFR, and MYC. So I'll define this list. Let's just loop through them for gene in gene names, print gene. That sounds good. And we can also we can add some text. So running or processing. Now, there's a few ways to sort of combine a print statement. This is and strings. This is kind of I guess will come up a lot. So maybe I'll just dwell on it for a second here. I can have this processing gene like this. So it's so it kind of concatenates, so combines this value here and this value here each time the print statement is run. A kind of much more modern way, and it gives you more control, is to create something called an F string. And I think this is comes up in a few languages as well. So you do everything inside the string, and you put the variable inside braces, so like that. And so then you can do sort of all funny things, and you can processing gene running, so you can keep sort of typing after having that variable there. Okay, So yeah, these F strings where you just have an F in front of the string, then you can kind of like put variables inside them. You can even do you can even sort of add things to it. So that's a string. So I can just do add X or something, and oh wait, no, that didn't work. Okay, never mind. Can't do that. I thought you could link strings like that. Okay, let's just do that. Cool. So processing gene, running analysis. Yeah, so that error was because I tried to, I thought you could combine two strings together. I think you can do that in some circumstances, but obviously not in that case. Okay, cool. So that's that. Let's keep going with this. So I'll go current concentration equals 0.5, target constant. Make sure you can do capitals, but make sure you don't make any typos. I've already made typos. Concentration equals 0.9, and reaction step, no spaces, equals 0. So I'm going to introduce something called a while loop. And a while loop means keep doing something until some condition is met, and then you can stop doing it. So unlike a for loop where it says for all of these values or for all of these numbers, do something, a while loop is like just keep doing it until something is true. And so that, yeah, if you don't know how long your string is or how long some number is going to be or how big it is, you can just keep running it until those conditions are met. And that's the power of a while loop. So while current concentration is less than target concentration, keep doing something. And we do reaction step. So currently equals 0, but I'm going to say update it to be reaction step +1. So that will add a 1 to it as well. And a little Python trick, you can actually you can sort of, it makes it more clear if you use this syntax called plus equals. And so it just means reaction step equals reaction step +1. So this is like a shortcut to do that. You can say just always add 1 to it anytime you see reaction step. So I'm going to comment that out. We'll use that version of it. Otherwise, it'll add it twice. So we'll add 2. And we'll increase the current concentration. So current concentration plus equals, let's say, 0.1. Okay. And so if I do this, let's just go print reaction step and current concentration. We can do an F string, actually. F R, and I can leave that comma there. It just becomes a number, and let's call it C. Current concentration, and close my braces. Okay, so we've got our current concentration defined here. Our target concentration 0.5, 0.9. It's going to check it. So current concentration 0.5 is less than 0.9, so that's true. So that means this will run. It's going to update this to step 1. It's going to update that to 0.6, and then we'll print them both out. And it's going to do that. Hopefully, it will stop when the current concentration is greater than 0.9. So let's see if that works. And there we go. So it ran through, and it updated them. Okay, it's done something funny here. This is kind of like this comes up occasionally. For all intents and purposes, this is equivalent to 0.8, but it's some sort of arithmetic rounding error, and so it's displaying like that. You can you can get around that by saying integer, and it'll convert it. Oh, sorry, not integer. How can you do it? You can say colon 1 should do it. 0.1. Is that it? Okay, let's see. Yeah, okay, so it basically forces the decimal notation there until it reaches 1, and then it says makes it in scientific notation at the end there. But that while loop is working as expected. If we didn't have this update thing, I'm just going to run this, and it'll just run forever. So it's just running forever. Probably don't do this. I'm just going to click stop. You should probably know how to do this anyway. When it's stop, I think there's up here, there's a runtime. You can interrupt the execution, basically pull the plug on it and say, oh, just cancel whatever you're doing. And you can see, yeah, it got high very fast because it wasn't updated. So yeah, while loops run into you can run into the problem of infinite loops. Okay, I'll put it back to that. Okay. Oh yeah, question from Sharon. Yeah, the rounding, it rounds it to 1 decimal place there. So that's a neat little function of F strings as well. There's a few ways to do that, and there we go. That worked better. Maybe one significant figure. I think on 1 point. I think that's significant figures, and that's, yeah, I can't quite remember the syntax, but yeah, the colon there, then and then afterwards you can put some extra details. I think you put letters as well there that make it into specific types of notation, which, yeah, can be useful. Okay, so good stuff. So that's for loops, that's while loops, and how we do with time. I think we've got time for functions here. Any questions? Anything? Oh yeah, so 1F. So F means float. F for floating point. I think there's D as well, which is maybe decimal or something. Yeah. We can Python F strings. There we go. F strings in Python. So there's a bunch of different ways to use them. Yeah, you can format with these percentage things to make it dates. Yeah, you can add numbers. You can do new line operators. It's all kinds of fun. Doesn't have the formatting, F string formatting. Maybe that's what we want. Oh yeah, here we go. 0.2F. So that points it with 2 decimal places. There's definitely more. Anyway, we won't dwell on that too much. Okay, so next in the notes. So indentation is crucial. We've done some for loops, we've done while loops. It's fantastic, everyone. So yeah, most programming languages have these concepts as well, and hopefully you can sort of read it once you see the Python code. I haven't mentioned I mentioned briefly that there's things called breaks in Python. So that's a way to escape out of a while loop. So in our version, I use the current concentration. Oh, sorry. Yeah, so we just use the current concentration. So this version in the notes has sort of 2 ways to get out of the loop, either if the reaction step gets too large, or if the concentration exceeds target concentration. So that's yeah, there's kind of a couple ways to do that. And what else? Anything else interesting that we've missed? I think we've done that. Oh yeah, there's ways to add additional items to the index, but I didn't go through that. To a list. Okay, so let's do functions, and then I think we'll be due for our first break. So okay, so a function is it's a way to reuse code, and the way that like code blocks work in notebooks, it almost like it helps you set yourself up to write functions anyway. So traditional Python scripts are just like one big block of text. It's just one page. You run everything all at once. But with notebooks, you can sort of jump around. You can go back and forth. So they're really powerful for doing that kind of thing. And functions, I guess, allow you to either to just reuse the same code again and again. And so the way to set yourself up with a function is to type in the word def, I think define, and then the function name. So let's make a Celsius to Fahrenheit converter. Celsius to Fahrenheit. Oh, look at that! It's auto completing it for me if I want. Oh, that's fantastic! It sort of wrote it for me. I'll come back and talk through it. So def Celsius to Fahrenheit, and then it says you open some parentheses, and you then say what variables need to be passed to it. So I'm going to give the function something, and it's going to give me something back. That's usually the way it works. You can either have functions that you can give multiple things to, or there's some functions where you give nothing to and it gives something back. So yep, so that's the syntax. You give it a name and then put a colon, and then start writing the actual contents of the function. You might see at the top 3 quotes, and then yeah, our temperature converter, written by Nate, converts C to F. There might be a note to do, make conversion F to C, something like that. So a docstring is basically, it's a multi-line comment, and you might see these around as well. You can put them sort of anywhere. They don't have to be in functions. You often see them at the top level of code, but it's just a way to write comments on multiple lines. Okay, so then to write our function, here we've got the temperature in Fahrenheit is equal to the temperature in Celsius times 1.8 and plus 32. So I think that's equivalent to what was in the notes, which was times 9 divided by 5, and then plus 32. And then it returns F. So if I run that, nothing happens. But now, if I copy this Celsius to Fahrenheit, and I have to, here it's saying temp C is not defined, and that's true. But if I now give it a temperature, so let's go 15, and if I run that, look at that, it ran through, did all this arithmetic and returned a number to me. So yeah, you can see, and then you can run that again with like 20. You can put this in a for loop for C in, you can do a in 10, 20, 30, 40. So I've got it in a for loop, and I can do for C in there. Actually, that's not going to do anything, but I can put that in a print statement. So you can make this, complicated pretty quickly. And so it does it 4 times. It goes through the loop and runs that function 4 different times. How powerful is that? That's fantastic. Okay, so that's the function. Let's do just a the one from the notes, the calculating averages. So I'll do def calculate average, and this one takes a list instead of a single numbers list. Okay, so calculates the average list, the average of a list of numbers. Again, comments are for the humans, so you can come and read this and be like, oh yeah, that's what that function does. That's fantastic. Often you see something like this, args number list. So these are the arguments. That's called an argument of a function. And you pass it a number list. and list of floats or int. And so usually it has a description for what each item is. Okay, and then we can say, and then we can actually write the code. Oh, here, we'll close that. Oh yeah, and there's often a return. So it says, okay, what does that function give me? And it might be something like float the average value of the numbers. Okay, cool. And then, so we can set up ourselves. So if not numbers list, so return, there's a few ways to do this. Let's just do return 0. So that's saying if this thing that you're passing me is not a, if it's empty or something, then it's just going to return 0. So it checks that. So that's some syntax we haven't seen. So if, and then this word not, it literally means like, it means not. So and numbers list, it should be, this will, again, the if statement needs to be sort of a true or false statement. So it's saying, is numbers list, is it true or is it false? And you can, basically numbers are positive, so if they exist, it'll equate to true. But if they are empty, then it'll equate to false. So that's what that is checking. Okay, so then we can do total sum equals sum. Okay, numbers list count len numbers list. So we've seen numbers list. Oops, count. That should be count equals numbers list and average equals total sum divided by count. Oh, sorry, the autocomplete feeding me then average. Good. So there's our function, and so we can do readings equals and so there's our list, and then we can send a list there. So let's do that. Readings. And so the average is 21.5. So again, we had a more complicated function there, and it's calculated. Okay, any questions about functions? We're going to revisit everything we've seen so far, like as we sort of get more into examples. So it's a good time to break here. I'll give you a 10-minute break, and we'll come back and do module 3. But just before we do, we have, we've seen the different data types. I haven't spoken much about like the style in Python a little bit, but there's whole books written on best practices for style. But if you just sort of copy code from places, it usually follows a style anyway. So we've seen some basic operators, and we'll come up against a few of these again. Yeah, we've seen all the different variable types. We've seen different data structures like lists, and we're going to see a few more coming up. We've dealt with some control flow and functions. So dealing with if-else statements, for loops, while loops, and yeah, functions at the end there. And so that will bring us to getting into some more serious libraries when we come back. So let's have a 10-minute break. And so I'll see you all in 10 minutes. All righty, everybody. We will get stuck back in. So just a question in the chat. Why did we do this if not numbers list? As we're about to see, if you write some really complicated function, or perhaps you write a whole catalog of complicated functions, you probably start putting in different like error checking and making sure people put in the right numbers and that the user is guided if they make a mistake and they didn't use the function right. They get told, hey, you didn't use the function right, or something else happens, so it doesn't just crash with no indication of what happened. So in that case, if we put in an empty list, calculate average, and we just send an empty list, which looks like this. It's just square brackets like that, and we run it. It's just going to return that 0. We could return something like empty list, and then we run it again. And so it gives us like an indication, like the person probably didn't mean to send an empty list, but they have, so we should deal with that case. If we didn't have this, so let's get rid of that. I'll redefine the function. So I run that again, and now I run it. We'll just get an error. It says division by 0. You might be like, hey, like I thought my list had numbers in it. What's going on? Why did I get a division by 0? That doesn't make sense. So yeah, you can help the user by putting in sort of different edge cases and troubleshooting. I believe there is. If you click down here, so there's a button down here where you click variables, and I think the first time you click it, it takes some time to load up and show you everything. I think maybe. I think that I haven't actually used it, so, but I know this button is there, and I know that sometimes variables appear. So play around with that and see if it works for displaying variables. I'm pretty sure that's what it does. Okay, so good stuff. Okay, so let's so we'll move on to the next section. We're going to talk about some libraries and just more data sort of handling. This is sort of getting into the fun part of things. Now we'll talk about a couple of libraries. Mostly, I think just NumPy and Pandas will be the two that we explore before we move more into the AI side of things. So a library, as I said, is basically a whole set of functions and variables and objects and different types that people have created and gone like, this will be useful if I give it to someone else. So then I have to recreate a Celsius to Fahrenheit converter. They can just type in F to C or something, and it will just work for them. So they don't have to worry about what happens underneath. And it usually has all the built-in sort of error checking and all that as well. And so NumPy, which is a big one, is one that you'll see all the time. It's really like optimized for doing numerical calculations. So I think it's actually, so the core of it's actually written in C code, and then it's exposed to Python. So C is really fast. You may have heard like, oh, Python's really slow. That's not really the case. Like, I mean, it is, but it used to be much worse. Now it's really good. And if you're using a library like NumPy, then under the hood, like the programmers who have written this and exposed these functions for you to use have sort of optimized it so it's super fast. Okay, and yeah, basically any sort of calculations you need to do on numerical data, NumPy probably has what you need. Another one that's quite popular is SciPy. So there's a lot of algorithms built into that as well. I think there's some overlap between the SciPy and NumPy ecosystem, and yeah, you'll see yeah, functions exist in these ecosystems, and you'll often find yourself in the documentation for these reading different, like what different functions do. Okay, so to use these, now in Google Colab, there's a bunch of these libraries that already exist. In fact, we can open up a new notebook if you like, if you want to, if you sort of want a fresh slate, or you can just keep using the same one. But you can type in import NumPy as NP. So, and if I run that, nothing happens, but now I have this new variable called NP, which has all the NumPy functions in there. And so it actually shows me all these options here. And we're going to use these functions in a moment. So the first thing, though, we'll set ourselves up with some data. So I'll make a let's call it a temp list pi. So this is a Python list, just like we've seen before: 22.5, 22.7, 22.8, 23.1, 22.9, so on. You can sort of make these numbers up if you like, or you can copy and paste it from the notes. Okay, so I have my list there. I'll just print it out so we can see it. Very good, looks good. And now what we can do is actually convert that list to a sort of a NumPy data type. So let's go temp, and they're called arrays in NumPy. So temp array NumPy equals NumPy. So that's a shortcut. So whenever you import like this library of packages, or you import a package or a library, it's the same thing. You normally type import and then the name of it, but I guess it's just convention that NumPy usually gets imported as NP. So you can say as something else. So some packages have really long names, and you want to sort of make things easy for yourself. So you can import it as like a little a shortcut. And so whenever we now want to use a function that is inside NumPy, we can do np.array, and then I'll pass it that list that I gave it, temp list pi, and I'll just print it out as well, temp array np. Okay. And so all that's done is just convert it to a NumPy object. So if I do type, like we did before, temp array np, it's a NumPy. It's called a NumPy and array. And so you can actually create Python objects and create your own data types and everything. So that's what the package maintainers of NumPy have done. They've created this object called a NumPy and array. And this object, this type of data, it has certain rules and different things that you can perform on it, just like strings and integers. You know, they have different rules. You can add two integers together, but we determine you can't add a string and an integer. NumPy array, you can add things to it, you can multiply things with it. But if you try and add a string or something, it'll be like, hey, I don't know what a string is. It's like, don't give that to me. So there's different rules with it. Okay, and so inside this, there's a few things that we can look at. So let me just, you can unpack what the objects are inside it. So I think if I do D type, it will say the array contains a bunch of float 64s. Now, that means it's a floating point number with up to 64 decimal places, which is different to a 32 decimal places, or you can have 16-bit, 8-bit. You can have 2-bit in some cases. Yeah, depending on how much, I guess, accuracy you need, and there's different reasons why you may use bigger or smaller numbers. And yeah, sometimes they can bite you when you're dealing with certain data, but yeah, something to be aware of. But usually it's fine if you're just doing normal things to trust whatever is the default. Okay, yeah, if you use like Microsoft Excel, you know, when you put like a really big number in it and it converts it to, like, it sometimes truncates things or rounds it up. Yeah, Python, I guess, suffers from that too, but nowhere near as badly. Okay, so for this, we can add things like plus 273 to convert it to Kelvin. And will that print it out? Yeah, so what that did is it added 273 to all of those different numbers. But if I did the same thing, temp list pi plus 273, it'll say, hey, I can't like add those things together. I can only concatenate a list, not an integer to a list. So yeah, NumPy has that advantage that you can add numbers to it, whereas a Python list, you can't do that. And you can do, there's a bunch of built-in NumPy functions. So I can do np.mean and temp array np. Oh, okay, so it says name error. This is really confusing, right? Like, it's name error, temp array is not defined, and you're like, hey, that is defined. But then you notice that I made a typo there, and should be a lowercase a. So reading and interpreting errors is like very important, I guess, what makes you a functional programmer. Okay, np. There we go. So that built-in function, numpy mean, it then returns this float value, 22.92, etc. So it took the average of all those numbers, which is super handy. And we can do the same standard deviation, np. Sorry, what's it called? Sometimes you can turn the helper functions off as well. I think somewhere in the Colab world, because sometimes they get in your way. Okay, cool. So that's the standard deviation, and you can do a max as well. So temp array ND. There we go. It's a float 23.5. So that's the maximum, which, yeah, checks out. Good stuff. Yeah, and there's a bunch of other things that will come up in NumPy that you'll see, but we'll move on to pandas. So pandas, again, we can import it. As I said, there's a bunch of pre-installed packages in Google Colab. If you didn't have something installed, which we're going to see later on, you have to install it from somewhere. There's a few ways to install it. You may have heard of like Anaconda, or you may have heard of PyPy or pip. They're sort of the two biggest package managers, and they host a repository of packages that people have written, and then like anyone can submit their packages to them, where you can then download them and import them into Python. And so you can do that all within here, as we will see later on. But for now, yeah, Colab has a bunch of packages already pre-installed. And if the next question is, how do I see what's installed? I don't know the answer to that, but we could probably find out. Okay, so yes, pandas. So pandas is very powerful, and we'll probably come across it if you're coming from anywhere like Excel. It's to deal with panel data or tabular data. And I think, yeah, there were a bunch of statisticians that invented pandas, coming from like somewhere like Microsoft Excel, where you've got all these different data types in a big sort of spreadsheet. This pandas is great for dealing with those data types, as we will see. So let's put some data in here. There's several ways to get data into pandas, and we'll see a couple of them. But to begin with, I'm going to define another built-in Python type called a dictionary. So data dict equals the data dictionary. I'll put it onto a new line so it's kind of easy to see. It's giving me some suggestions, but I'll follow the notes here. So I've got sample ID, and we can call it S1, S2, S3. Very good. Okay, and then a comma. So a data dictionary, I guess it's pretty similar to JSON format if you've seen. This is a Python type, so not pandas yet, but it can hold, sort of has a key value syntax. So over here is the key, so it's like the name or the column header or something, and then here is the data that is associated with that key. And you can embed things like you can have lists of lists, and you can have dictionaries that contain NumPy arrays, and you can have dictionaries that contain all these different data structures. So you can have these nested data structures. And you can have lists of dictionaries and lists of dictionaries that contain lists. So it can get very complicated, but sometimes that kind of makes sense. So if you have like some weather data, and the weather data may have like information about like where the data was collected, so some metadata about like latitude, longitude coordinates, and then it's got the data itself. So you can imagine that that's all stored in the same data structure, and that's why, yeah, these data structures exist. Okay, so treatment. Okay, let's go control. Drug A, drug B. Very good. Okay, good. I'll keep going, actually. Control. Oops. Make sure you close the drug B, and so on. Good stuff. Is that going to work? No, I need these lists to match up. Sorry. So I'll need those to be consistent when we look at it. 3 and 3 and 3. Okay, next one, measurement. So I've got a bunch of 0.15, 0.78, 0.20, and replicate. Okay, again, I should be consistent with how I'm typing here. 1, 1, 2. Good. So that's my data dictionary. I can print that back out just to make sure we've looked at it okay. Fantastic. And now we want to convert it to a data frame. So data frames are great. It's a pandas data frame, very similar to an R data frame. And we can usually call it something like DF experiment. Oh, there we go. It's going to finish it for us. PD, so pandas. So we're introducing just like we did with NumPy, the NumPy array, we're using a pandas data frame type, and it's going to automatically convert this dictionary into a pandas data frame type. Experiment. Okay, cool. So look at that. Yeah, it looks very similar to an R data frame, I think. So it has a key row number here, and then the column headers, and then the values for each of them. And so the difference between, I guess, NumPy and Pandas, NumPy can't handle strings and mixed data types, can only handle numbers, but it handles them really, really well. So that's the difference. Pandas is, I guess, slower. Okay, and now we can explore different parts of pandas. So we can do df experiment.info. There's all these different functions. So this is called a method. So this is the data type. This is like the data, df_experiment, and it's kind of like a function, but instead of calling the function and passing it as like an argument, you you sort of tack it onto the end there, and Pandas has a lot of methods. But yeah, it's just another way to kind of to interact with a data type. It's yeah, basically a function, but a different way to use it. Okay, cool. So yeah, it gives you some idea of the data straight away. It says, you know, how many values are in there, if there's any data that's missing, and it also gives a type. So these are objects. So an object is usually like a mixed type or a string, and then it's got floats, and then it's got integers. It says how big it is, what the memory is. So it's very handy, this little info command. You might even be able to do, I think, if you wanted to do it the function way, will that work? df experiment. Oh no, so you can't do it that way. I thought you might be able to. So yes, it's kind of like the equivalent of that though, a method. That's how you would if it was a function instead of a method. Yeah, there's different scenarios require sort of different ways to do it. Okay, you can do df experiment dot describe, and that will give you some summary statistics. So how many are in there, the average, the standard deviation, and so on and so forth for the values, for the numerical values, and then I think it automatically ignores the mixed type or the strings. You can do df experiment dot shape. Oh wait, okay, sorry. So this shape command, you don't have the parentheses. And again, that is, I guess there's slightly different reasons. I probably could describe why some cases you use the parentheses, sometimes you don't, sometimes you have, yeah, it's like a function instead of a method and so on. But yeah, you can just know that occasionally things appear like that. Okay, what else have we got? Oh yeah, you can access different values in it. So you can access a row, or sorry, a column. So df experiment. The way to do it is to put the name of the treatment, and that will print out the row. And this becomes, so this is called a data frame, and a single column is called a Pandas series. And so yeah, you have a Pandas series here. You can access these in kind of different ways, but that is one way. And we can subset the Pandas series as well. So Pandas is quite good at experiment. You can go df experiment treatment. Oh, there we go. Treatment equals drug A. So we'll just print out, experiment, df experiment is not defined. Experiment. Is that it? There we go. So you can subset the data sort of seamlessly with Pandas. You can do df dot lock 0. Does that work? Oh, sorry, df underscore experiment. So what do I want? No, iLock. Oh wait, I always forget this. But Pandas indexing is 0. Like it? Yeah. Okay. So div experiment dot iLock and then square brackets, and 0 will give me the first or the 0th row, which is this one. So you can get the next one and so on. Yeah, but yeah, this is all in the documentation, and obviously if you need to do something, just say, hey, how do I do this? And normally searching or something will get you there. Okay, is that all I had for Pandas? Oh, cool, that's great. So I think that's all I had just for an introductory to Pandas. We're going to use Pandas in the next section as well. Any questions? Oh, thanks, David, for answering that question about shape. Good stuff. So Yeah, so Pandas is used a lot in exploratory data analysis when you sort of want to understand your data and think about it and see how to approach it, which we'll do a little bit in this next section. We're making great time, so that's fantastic. Now we'll get into AI, and there's a few. So AI as a concept, it's I think much bigger than just like ChatGPT and Gemini and asking questions and it giving answers. That's called I guess a large language model, fine-tuned on chat and on answer response. But AI as a concept is much bigger. It's like part of the field of data science and maths and statistics. And then machine learning is sort of a large part of it as well. And so machine learning is more about sort of making predictions on data you have. So stats is probably like understanding the data you have, and the machine learning, I guess, is making predictions about data you don't have, perhaps. Maybe that's one definition of it. And then within machine learning, there's something called deep learning. And deep learning is a specific type of machine learning where you train data using something called neural networks. And neural networks are based on, I guess, they're sort of similar to how neural pathways in your brain actually respond, where different parts light up and there's different ways to get there. And so if you feed information going in, and then on the other side, there will be some interpretation of that information on the other side. And that's sort of how these neural networks work. And that's the foundation for sort of what we know as AI, I guess, in the sort of ChatGPT sort of idea. And so we're going to go down this pathway of loading in different models and sort of exploring, what they do and how they work, and just to get you comfortable in the ecosystem of how do I download a model, like how do I use an API to request a model that's in the cloud. That's sort of the goal of this. Okay, and so I didn't have any examples for sort of the prediction part of machine learning, but it's a huge part of it, and I can talk a bit about that as well, especially if we have time. So you've probably all experimented with LLMs so far, using sort of web interfaces, and they can be super helpful with summarizing documents and literature reviews, and brainstorming a hypothesis, and drafting emails and things, and understanding concepts, and also writing code. Like, fantastic for that. So I think that they're the biggest use case for them, and sort of understanding like how they work and demystify them, I think can help you use them like better. You can sort of you sort of know, like, if I ask this question, it's probably going to hallucinate and make things up, or if I ask it in this way, I'll probably get a better response. So I think that's good to know. Keep in mind, data privacy as well. So we'll download a model locally, so that way your data is not going anywhere, and so that can be really, really useful if you need to do something on private data, but you want to have the power of a local large language model. And we'll also use an API as well for when our local machine is not powerful enough. Okay, so let's I will, again, I'll start a new notebook for this one, but so let me start a new notebook. And the first thing we're going to do is install a package called Keras Hub, and that's going to allow us to sort of download models. Okay, and that'll take about 30 seconds, I think. All right, so I've connected. So the way you do this from a notebook is do pip install. What was it? I'm going to do -u and Keras Hub. So minus capital U and Keras -hub. And I'm going to install that. That should take about 30 seconds. So what this is doing, I'll go to the website while it's installing. This is the same thing you'd do if you weren't in Google Colab as well. You use pip usually on the command line or within the Python package manager that you're using. So it's saying, okay, it's actually Keras Hub is already in Colab, but we're updating the version from 0.18 to 0.21. It's saying, oh, it's already got all these things in Google Colab, but it's just updated Keras Hub for us and done. And saying there's some sort of error which I don't think matters. It's just saying it couldn't take into account updating every single package in this ecosystem, which is fine. So it says successfully installed Keras Hub. So let me just I'll go to PyPy, where we've installed this thing from. So it's the Python package manager. I'll go Keras Hub. And so Keras Hub is a package multi-framework pre-trained model. So it's designed for for dealing with LLMs and the models and sort of getting them into useful formats that we want, and then using them to ask queries and whatever we need to do. So you can imagine, writing those functions from scratch wouldn't be very fun. So using this is very good. And it's the models, they plug into Kaggle models. So we're also going to have to go to Kaggle and do a few things there. So this will be so we have to be careful here and sort of make sure we tick all the boxes here to in order to use this package Keras Hub. And the side question, when there are dependency conflicts while installing packages, will the incompatible packages not work, or will they still work but imperfectly? Good question. Sometimes they'll work. Sometimes they will fail quietly. Yes, so sometimes you won't know it doesn't work until everything's installed, and then it will go to load some function and it'll crash. But a lot of the time it won't install if there's an incompatible package. So in which case, building a new environment is good, especially if you're not in the Colab environment. If you can just build a new Python environment for whatever work you're doing is usually the best way. So we haven't dwelled too much on Python package management, but it can be a real pain in the ass. So some of the as a package gets updated and then another package like it relies on becomes incompatible with it, so then they have to update it, and so all these packages are sort of updating all the time. Some things get forgotten about and just people stop. A lot of this is open source, so people stop working on the project, and so people are reliant on that package, and maybe it's not compatible with new versions of Python. So anyway, dealing with a compatibility of all these packages can be frustrating, and especially in like the AI field, like things are moving really quickly, so they're getting updated like very, very rapidly. So that could come up. Anyway, we'll hopefully not experience that today, but we're going to go to Kaggle and we're going to set ourselves up so we can download the Gemma models. So if I click this link, will that take me there? Yes. Okay. I'll put this in the chat. Okay. So now hopefully everyone can log into Kaggle. I've just logged in with my Gmail account here, and now on the Gemma page, you can see mine says you've consented to the license for Gemma. If you, I can't remember exactly what it looks like, but there should be like a button where you say like I consent, and make sure you click that, and you can then download Gemma models. So a lot of these, the weights of different large language models, they have different licensing So you may use it for research, may not be able to use it for commercial purposes, or maybe you can't use it for retraining stuff, or maybe you can only use it for retraining. There's all these different things. Generally, the Gemma models, they're open models, so you can do most things with them, but you just have to accept the license agreement. Okay, so once you've done that, we can then download them. Excuse me. Does anyone have any issues with that? So then, to download it, you can, I think there's like a download button probably. You can just click download, but oh yeah, it came up with some options. So different, I think it's basically all Python. Oh no, so there's different ways to download it directly from Kaggle. So if you're not familiar with Kaggle, it's basically a machine learning platform. It started as a place to host machine learning competitions. So people would come and say, okay, I've got this massive data set, but like I don't know how to interpret the data, or I want to train it to predict these things. What's the best way to train a model to predict the answer? And so you can get people who have no sort of domain knowledge, but they know a lot about sort of training these sorts of models. And so all these Kaggle competitions allow people to sort of leverage that expertise in order to do that. And one thing they do is they host models and notebooks and data sets as well. And so we're using it to download the models. There's a bunch of other ones as well. So Hugging Face, I think, is probably the other big one that you'll come across. So Hugging Face also hosts models, and I can't think of any more. But there's a bunch of other places where you can download machine learning models from and interact with these websites. But today we are using Kaggle. So you can just click here and download the model as a zip file. It's a couple gigabytes, but once you get it, you have to do something with it. So mine's sort of downloading now. But we're going to call it directly from our notebook and download it into our notebook environment. Okay, so lots of sort of roundabout ways, but I knew this would take a while. Okay, in order to do this, we have to set up what's called an API key. And this is true for if you want to use like OpenAI or Meta, what's that one called? If you want to use Meta, or if you want to use or the Google Gemma models or anything, you need to create an API key, which is, it's like a username and password, so you can connect to the website and download stuff. And so this is sort of an important skill to learn. It's usually in the settings page. So I'm on kaggle.com/settings, and down here I have to create a new token. So this API will let me interact with things. So I'm going to click create new token, and that will expire any previous key, so that's fine. I'm going to click OK. Okay, and it's just downloaded this, which you probably can't see, but it's just it's what's called sorry, let me just open it and get it into the window for us. Okay, so there we go. All right, so it is basically it's a text file, or mine's called kaggle.json, and it has my username and what is essentially a password. So never show this to anyone. So it's very, very, very bad to share this. But you basically get this password file, and then I use that whenever I want to use the Kaggle service. And like I said, it's true for any of the sort of large language model hosting services. You have to create an API, then plug it in and say, oh yeah, use that API to connect. So that way they know who you are, and they know what you're doing, more or less. And in our case, all we're doing is just downloading the model, and then we sever our ties with it. If you do expose your key, like in a online workshop by accident or something, you can just revoke the key So I can go back here and click expire token, and then that thing is now useless. So I can create a new one, and so that's the beauty of these these tokens. All right, so I'll probably expose my new one too, but that's okay. I will make sure to expire it at the end of the session. Okay, so back to the notes. So they're all here. Go to your Kaggle login, create, go to setting, go to API, create a new token. You'll get a username and the key, and you also have to accept the terms of service. Fantastic. Now let's move on to the next few steps. Okay, so I'll go back to where I was. I've installed Keras Hub, and now what I'm going to do is import it, Keras_hub, and I'm also going to import another Colab one that's already built in called Kaggle Hub, and that will. Okay, any questions or concerns or anything at the moment? We'll log in, and then we'll try and get this first one up and running, and then we'll have another break. Okay, so then now I have to just log in. There's quite a few ways to kind of connect to the service, but this is probably the easiest. Is you go Kaggle Hub login, just like that, and click run, and it pops up. What is your username? So I'm just going to go to my document downloaded, and it's just it's just a text file. You can just drag it into Chrome if you need to. I'm just going to copy my username and my key that was generated, and I click login, and good stuff. My Kaggle credentials are successfully validated. How did everyone go? Good stuff. Fantastic. All right, so now we can grab ourselves a model. And again, there's a bunch of different ways to kind of like get the models. Like before, I just click the download button. You can do that, but then you have to import it into Python and unzip it and get it into the right format. So what we're going to use is the Keras Hub framework, which kind of like does all that for us and puts it into a format we can just use. So I'm just going to create a new variable called Gemma, and I'm going to go Keras Hub dot models dot Gemma 3 causal LM dot from underscore preset open brackets, and then the name of the model that I want, which in our case, I'm going to get Gemma 3 underscore 1B, and I'll talk about these in a second. And I'm going to go next, and that'll probably take about a minute to download. Yeah, you can see it going. I think it's about 1 gig or 2 gigabytes in size. Remember, we're working in Google Colab, so it's, when I say download, it's downloading it to Google, to the to the cloud. So you're working there. And if I go back to Kaggle, you can see, let me look up Gemma models. So we are downloading, we want Gemma, oh no, I have to look up Gemma 3, which is different. So Gemma models have been released in a few different formats, and they keep getting updated. So we're downloading this one, Gemma 3 underscore 1B. Now that means it's got 1 billion parameters, and that's about the smallest size model you'll find these days. You can see these other ones, 12 billion parameters, and they get bigger. So the Gemma 3 models come up to 27B. So that would be quite large. It would probably be maybe like 30 gigabytes or so in size. So that would be hard to work with. And the computer that we're running on, in our case, our Google Cloud instance, would have to be big enough to sort of run that model as well. But we don't have that much compute capacity in the default Google Colab. Okay, and there's a few other options that I'll just talk about. So you can see there's this one called text. There's also these ones called instruct. Now, there are slight variations in the model, and we'll experience how they're different. These ones without any prefix are kind of your base models. They're kind of untrained. They're almost a bit wild, I guess. They're usually used for then fine-tuning the model on maybe a local data set. So you start with like something, this model that has been shown all these sort of examples of what text and language looks like. It's been shown lots of code examples, but it doesn't know what to do with any of that. So then these instruct ones, we'll download one of these as well. These have been trained on question answer responses. So that way it knows if you say like, what's the capital of France or something, it knows to answer with a logical response like Paris. It doesn't try and do something else, that it doesn't try and write code based on that question or something, which you could train it to do. So you could train it, be like, oh, okay, do I know any code named Paris or something? And let's go from there. Okay, so and you'll see that these other variations as well. We're using the Keras version, but there's also a PyTorch version, Transformer version, C++ version, and all these couple of other ones, Flax as well. So they come in slightly different formats, and because each of these different frameworks or packages, they have sort of a different way of interpreting data. Like they might use columns instead of rows, or they might have the weights in a certain format or something. They might use 16-bit instead of 32-bit. So there's all these like slight variations in this ecosystem, in the large language model AI ecosystem. I mentioned it's moving really fast. So standards are developing, but there's still a lot of variation. Okay, sorry, I'm talking a lot in this section, but that's, I think that's okay. All right. So downloaded my model, fantastic. I think I've got, you can actually explore. So just exploring in Google Colab. Oh, actually, we'll just get the next question running. So now we have a model. It's ready to go, and we can do something with it. So so if I just write Gemma, it'll say, yep, cool, I'm this type, I'm sitting there waiting to do something. Yeah, you can type and it'll probably be a it's a yeah, it explains, this Gemma 3 causal. It's a very weird type, but it does have a type. It's just a Python object. But what we can do straight out of the box without much work is type Gemma, generate, and say Keras is I'm going to max length equals 50. And that's going to ping our model, which is stored in this Gemma variable. And it's using the generate function with these arguments. The argument is, this is sort of like the question you'd ask that large language model. And I'm just saying, just give us a response of 50, because otherwise I don't know what the context length of these are, but they can be very large. So it might write pages and pages of information until you tell it to stop. Okay, that'll take about a minute or so, I think. While we're doing that, I'll just show so Google Colab it's a computer in the cloud somewhere, and we can actually explore sort of where that data was downloaded to. So I'm just going to go over here just for fun. I think it's in the root directory. Okay, I have visible. You can hide invisible files or show them. So I've just unhid them, and where I said, I think it's in cache, Kaggle Hub, models, Keras, just to unpack things so you know exactly what's happening here. There's no magic happening. Gemma 3, there we go, it's getting there. And so here's the model that we downloaded. So it has a config file, which is in this JSON format, which is just text basically. Let me open that up. Let me open that file that I just downloaded up so you can see it. yeah, nothing exciting here. This is like the metadata of that. So it's saying, you know, what type it is, and it's giving some information that what went into the model training. So these are all sort of options in the training training configuration. Okay. And then the weights. So the weights are what the model knows. I was talking about the neural network before. So as it goes through the network, at the end of it, it creates like these weights. And the weights are basically determines what goes in, and then things get weighted. So if you ask Keras is A, and then the weights will sort of determine how it bounces through the network and what comes out the other side. So that's the big file. So I won't download that one, but it's in HDF5 format, I think, H5 format, and I think they're the two most important ones. All right, so it has written, Keras is a deep learning library for Python. It is a high-level API for neural networks. It is a Python library for deep learning. It is a library for deep learning. It is a library for deep learning, and you can see it's a bit crazy. Like this isn't, it's not a very powerful model, as you may have experienced with something like Gemini or ChatGPT. So it does some crazy things sometimes. It's only a 1 billion parameter model, and it's used for very like specific tasks. So we'll talk more about that shortly, but let's have another break. So we'll come back in 10 minutes, and we'll keep going through the motions here. If you think of any questions, post them in the chat, and I'll have a look at them over the break as well. Okay, and I'll get back to them. Set a timer.
Hello, is Nate or anybody else there, please?
I am still here.
Yeah, sorry, you're not getting your break, mate. I had trouble getting into Kaggle and it just didn't like my name, so I had to make a name up to eventually get in. So I'm running behind. I'm trying to catch up from the instructions there. So I've got the API key, then it said accept Gemma terms of service. So I've gone to that link, and it says scroll down to the bottom and accept the terms of service. But I can't find that. So what I'm seeing is model details, Gemma model card, model variations, about variations, example use.
So maybe it's at the very top. So you can see on my screen.
Yep.
What does the top here look like? Just under the
model card. Oh yeah, request access to the right.
Yeah. So maybe click on that one, and then I think.
Okay. Yeah, that worked.
Good stuff. Yep.
Okay, mate. Thank you. So I'll try and catch up.
Yep. No worries. Yep. We haven't moved much past that. So
yeah,
good stuff.
Thanks, Nate.
Alrighty, everybody. Let's get back into the swing of things. We just hopefully updated and installed Keras Hub using pip. We imported Keras Hub, this Python package. We imported Kaggle Hub, another Python package. We use Kaggle Hub to log into Kaggle, and we use Keras Hub as a framework for both downloading things from Kaggle, but we still need to be logged into Kaggle, and also for using some of the framework around interacting with large language models. So if I go, so one of the questions in the chat was like, what is this command here? So Keras Hub is the package, and then if I go, let's look this up, maybe that. Okay, is that what we want? Gemma causal LM. So within Keras Hub, there is a, I think it's a, is that a class API documentation. So if I search model somewhere, oh, maybe that's as top level as we can get. Well, it has this model API, which lets us sort of interact with anything to do with a model. But then within that, there's like a subset of of causal LM, which lets us interact with large language models specifically. So there's other models that it can deal with. So I haven't spoken, I spoke briefly about general machine learning models, which are used for like prediction. But there's also things like vision models. So that's used for computer vision, where you might want to perform tasks like recognizing what is this object in the picture, and that's a very different kind of framework to like a large language model, where you're saying what's the next word. Like they're trained and operate sort of differently. And then there's also like image generation models, where you give it a text prompt and then it creates an image. So that's also sort of different again to making a large language model call. So there's all these different branches and models. So that's why they have sort of this subclass and then the causal LM class. But then they've made a specific what's the one we're using? Gemma 3 causal LM, which may not even be, is it documented somewhere? It's buried in the notes there, but it's not. Gemma search instead of Gemma 3. Oh yeah, there we go. Good stuff. Yeah, so this is relatively new. This particular class. So class is, it's kind of like it's smaller than a function, but smaller than a Python package or a Python library, but bigger than like a function. It's a set of functions and types and everything that you can create your own classes, and you can bundle them all together and then perform operations on them, like the methods that we saw before with pandas. So this is a specific class, and the documentation is there, but we won't worry too much about the documentation. It could be somewhat overwhelming. We'll just use the bits and pieces from what we've got. Okay. Oh, and even explains what the different models are available within this particular class are. And yeah, so from each of those model types, you can probably go and read the documentation for how to interact with that particular model and what the best approach is and everything. So transformers and so on. Does it, if I click there, will it take me? If I click download, no, that won't help me. Okay, hopefully that answers that question. Okay, so we have generated this text. Now, yeah, so this type of model, it's sort of what the original large language models were. What they're trained on is text, and you show it some text. So you show like the quick brown, and then you show it whenever you see the quick brown and then you show an answer, and the answer might be fox, and so it knows, like, it tries to predict what's going to be the next word after the user says the quick brown, and it's going to be like, oh yeah, the fox jumped over the lazy dog, and it will. That's sort of the nature of these models and what they're sort of trained to do. And so this base model is built on that premise. If you ask a question, so let's ask a question of our model. I think my runtime is still active. If they're dormant for a while, they sometimes go to sleep and you have to restart it. So Gemma generate. So what year did Titanic win an Academy Award for Best Picture? Okay, and I'll do max length equals 50. So let's ask it a question, and you'd expect now, for those that don't know, I think there's two Titanic versions, one for in the 50s and the more modern one in, when was that, like 99 or something. And I think the 1998, I think that one won the best picture. So that should be the answer that we expect. Like, yes, it won it won it in 1998. So it should be smart enough to understand you know, that there's two Titanics, but it didn't win it this time, and that's the ideal answer that you want. But instead we get this: what year did Titanic win the best picture? What year did, and it just keeps repeating itself. That's because this model hasn't been trained on questions and responses. It doesn't know what, like, I guess it doesn't know the concept of a question and to give you an answer. So you'd either need to fine tune it on a series of question responses, which is what you might want to do, especially in a research setting, if you had, you know, a specific use case and you just wanted like a particular answer, that it can be good for training it on your data. But the good people that created Gemma, the people at DeepMind, that they have released a model that does question and answering generally, not fine-tuned to anything, but they have these instruct models. So I'm going to grab this next one, causal 3. So it's almost the same, except it's the instruct 1b. So I'm just going to kind of overwrite the one I've got, and I'm going to instruct 1b. And so we'll download that one. That'll take a minute, and then we can ask this one questions. So yeah, I wanted to sort of teach you the different types of models, because there's so many and it's really overwhelming. All the variations in models, and you're like, which one do I get? Do I get the 1b? Do I get the instruct? Do I get the do I get, you know, this flavor? So it all depends. Okay, so hopefully, I think that will take about 30 seconds. Hopefully this works. Yeah, we may, okay, it crashed. That's okay. I thought that might be the case. Yours may have crashed too. So we probably ran out of RAM or something on this on this virtual machine. There's a couple of tricks around this, which I wanted to show you. So up here you can click runtime, and you can change the runtime type. Now currently we're using a CPU, and we're using Python 3. You can change this to, you can also use R in Google Colab, you can use Julia, and you can use things called tensor processing units, TPUs. They're basically the same as a GPU, except they're specifically designed for deep learning and large language model questions and training and so on. So you have those options, or you can use a T4 GPU. I think the TPU would be best in this instance because it actually gives you lots of RAM, which I think is kind of like what you need to have multiple models in your in the one Colab environment. Anyway, so that exists. You can do that if you like. I won't do that. I'm just going to restart mine, and I'm just going to skip the part where I load this first one in, because I don't think we'll need that one anymore. So I'm just going to not load in two models at once. Okay, so I just need to, and I haven't spoken about saving or anything. This is all saved automatically in your Google Drive. So mine's just called Untitled 3. I can call this like LLM demo or whatever. And I can move it later, but it's all been saving automatically. And so I've completely restarted. Now, if I type in Gemma, like before, it knew what Gemma was, but now it's like, hey, Gemma's not defined because the whole thing's restarted. Okay, so hopefully I haven't lost anyone on that. Okay, and so I'll delete that. I can keep that there or whatever. So let's go back up, and I think I'll have to reinstall Keras Hub. That is, unfortunately, sometimes you have to reinstall things. Sometimes it keeps the installs in like the same session. I think in that time, actually, it did keep the install, so it didn't need to install anything. I do need to reinitialize with Kaggle Hub, so I need to go find my my key again, and that one working. It's thinking. Taking a while this time. Yeah, were there any questions while we're doing that? Oh yeah, okay, so that's worked. Good. Login, so my username and my password. Good stuff. I've logged in, so I'll skip the first model. And so that one won't work either. We'll come back to that in a second. I'll download this one. So that's the other thing. In notebooks, they don't necessarily have to be in order. Like, I can execute this bottom one first and then go back up and run this, and it'll know what Gemma is. That's not good practice, but like sometimes when you're just kind of hacking around and exploring sort of what you do, but yeah, not great practice to do that. So that should load that up, and then I'll rerun this question one, see what happens. Should take a minute. Good stuff. Okay, got my tick there. That means it's finished. So now let's do both of these. Let's do the Titanic question first. What year did the Titanic win an Academy Award for Best Picture? And I think that'll take 30 seconds. I think in the original notes, I put all the times in because I knew they all took a little bit of time. Where am I? This one, it's thinking. Now remember, this is the 1B model. And so, yeah, like in an ideal world, you know, you want to maybe always use the biggest. I think some models are like 400 billion parameters or something, and they are huge. You have to burn down a portion of the Amazon rainforest to ask it a question, but so like, you know, but you'll probably get a really good answer with those ones. However, yeah, there's, I mean, besides the ecological footprint of them, it might cost a lot more, like in terms of computational like hours. You'll be running on an expensive GPU, whereas these 1B models, they can run, you know, they're running in a free notebook here. I think the 4B ones work okay in here as well, probably the 7B as well. But 1B, yeah, will be on smaller devices, and you'd probably get them doing like really specific tasks. Like you just want, like, maybe you just want the next word, or like you might pass it some text and say like true or false for which of these items is true or false or something. Like you just want like a really simple task for these small models. Okay, so this one, what year did the Titanic? Okay, this one gave me the question back, and then it said Titanic won the Academy Award for Best Picture in 1953. So I don't think that's true, but it's, you know, it's much better than our first result with the non-instruct model. It actually gave me an answer to the question that I asked, even though it didn't give me the correct one. I want to run this one, see if this Gemma.generate probably give me a similar sort of response. Because I think it knows question answering, but it also knows predictive text as well. So we'll see. And any other questions or anything about just these models. There you go. Keras is a powerful, flexible library for building neural networks in Python. It provides a high-level API that simplifies the process of defining training models. Here's a breakdown of key aspects, and then I think it got truncated by the max length we set. All right, good stuff. Now, the thing with this though, we can ask it like if you've used like the Gemini interface, you know, you ask a question and then you ask another question and you go back and forth. That's because all the questions you ask it and the responses, they all get added to like the context, what's called the context of the large language model. So the next time you ask a question, it actually passes all that information back to it. So if I ask a follow-up question here, so let's see, what other awards did it win? It'll basically have no idea what I'm talking about, like, because it's lost the context. So this is the only information it knows. And so that's the other thing to keep in mind when we're using like the Python implementation of it. We have to do all that extra steps for us. And that's why sort of the chat interfaces like Gemini are so popular, because they're easy, they've taken out all the hard work. And yeah, I don't know, well, that is kind of related to films, but I don't think it's got anything to do with the first question we asked. So what we can do, what we're going to do as a task, is to write ourselves a function which builds up a chat history. Okay, so and we'll store it in memory, and then when we send it to the model, it'll have a whole chat history there. So I'm going to write a function. So follow along. Let's go format Gemma prompt manual, and we want the history. So I'm going to follow the notes there. Hopefully everyone is with us. So let's chat with a conversation history. Format Gemma prompt manual. I'm going to basically replicate this. You could copy and paste it, but I'll type it out for just so we can explain the code as we go. So remember, function format is you have the keyword def there, and then the name of the function, and then this will be an argument in our function, and we can give it an explanation. Remember our LLM conversation. Okay, good. So let's start by declaring an empty string called prompt. So when you talk to a large language model, you have to give it a prompt. So that's sort of like the input to the model. So input is what's called a prompt, and we get some sort of output, which is usually like a text response. And so we're going to start by declaring just an empty string. So we'll go from there, and then we're going to say for turn in history. So that is for the I think yeah, language has this concept of turns. You know, it's my turn to speak, it's your turn to speak, it's my turn to speak. And same with large language models, they have a concept of turns. You know, it's your turn, my turn. So we're going to define something called a role. So that will be the user, either like that'll be us, and the model. So role turn is role. So this will be a so for turn in history. So this thing history will be basically the conversation that we pass it. So maybe we should define that first, so it makes sense. Yeah, so history will be, I'm just going to do this here. We can modify this later. It's going to look something, we're going to define it as an empty list to begin with. And we didn't talk about this earlier, but we will, oh, sorry, I'm going to call it conversation history. Conversation history will be an empty list, and we're going to add a dictionary to it. So, and it's going to look something like this. So conversation history dot append. Now I briefly mentioned these other functions that exist for lists, but if you want to append an item to it, so we defined the list earlier. If you want to keep adding items to it, you can use the this function called append, or this method. And oh, there we go. So it's looking like it knows what I'm talking about. So we're going to add a dictionary to our list, to our conversation history, sorry. The role will be user, and the content of, so we'll pass it our persona, which is the user, and also some content, so like the message we want to send. And that question could be, what year did Titanic win? Okay, we'll modify this later, but just so we can see what's going on. And we also, is that what we want? I think that'll yeah, I think that's good for now. So we have a dictionary there with I can maybe I'll make it like this so we can see it a little bit better. You don't have to, but just so you can kind of see the see sort of what it looks like. So we're going to append this history. Every time we ask a question, we want to save that and add it back into the prompt history. Okay, so we have a role, and if the role looks like, sorry, it's going to look up turn role, and that will turn into the word user when it grabs that. And so the other thing we need to get is I think it's the content. That's the other one we want. Content equals turn, and that one's called content. So if it grabbed this, it would be, the answer would be user. So it would set role to user, and content would be what year did the Titanic win. Okay, now we're going to say if the role equals user, then our prompt, which is currently just empty, we're going to say add it, add. So plus equals, add some extra sort of information to the prompt. So I'm going to add an F string to it. And large language models, they sometimes have like, special word, but generally not. You can kind of make them up as long as it's kind of clear. So this is, I'm just using like some angle brackets there. So start of turn. It doesn't have to be this. It could be, you might see it in like different syntax. But user /n, and then content, and then end of turn. Okay, this is a lot to unpack. I said that we'd go from the basics and ramp up quickly. Okay, so it's an F string. All this is that's just plain text that we pass to LLM. This one's a special character. This means make a new line, and this is the content. So that will be the value of what year did Titanic win, and then the end of turn, and then another new line. So we're going to add that to our prompt. So that goes to LLM. And then the next thing we want to do, if, so elif, let me space this out a bit, elif the role equals, we haven't made this one up yet, but if it's the model talking, so that's if the model's responding, we basically do the same thing. I'm just going to copy that prompt, make sure I get the indentation correct, and I'm just going to change this to model. So that's it. So that just means when you pass it, when you pass a conversation, it'll have this block of text which says this is the human talking, this is the model talking, this is the human talking, this is the model talking. And so every time you ask a new question, it'll just append to that conversation history, and the large language model will scan through it all, be like, yep, okay, that's the conversation history, that's the context, I'm the model, you're the user, I'm going to answer it correctly. Hopefully that's the case. And then we can put an else statement, say print something went wrong. Okay, cool. So, and then at the end, we need to also add one more thing. This is where I was talking about making sure you're out of the, so we want to be out of the for loop. So I need to reduce my indentation once more. So that's all in the for loop. Then I'm out of the for loop, but still within the function. And I always want to add, every time the function call is called, I want start of turn. Oops, I pressed tab, but I want the model there. So that means the human always has the first go, and then the model's always going to have the next go. Okay, and then return prompt. Cool. So let me save that. We'll see what errors we made. I'll make that little conversation history, and let me then go prompt. Let's call it prompt 1 equals the name of our function, which is format Gemma prompt manual. So I'm manually formatting this, and I'm going to pass it the prompt history. And I'll print it out just so I can see what it looks like. Cool. So, yeah, at the moment, that's all we've done. But now, if we then wanted to append things to it, we can see what happens. So let me fix this up. Let me go, what year did 10 ick win the Academy Award for Best Picture? Okay, I'll re-instantiate that. There's my prompt 1. And now I'm going to call the LLM. So let's do Gemma.generate. And I'm going to pass it prompt 1. And maybe that should do. We'll see what happens. Maybe I should have put a max length on there as well. Oh, and I should have captured it also. So while it's thinking anyway, response equals, so you normally want to capture the response, and what else do we need? Do I need to do anything? Yes, okay. Let's go. Oops. Let me fix up this max length equals, we'll set it to 100. In fact, I might, maybe it's worth killing this, because I don't know how long the length will go for. So I might just kill that without the max length in there. Yeah, smarter models as well, they kind of know when to stop. Some of these simpler models, they just keep rambling until they run out of context. Okay, that's fine. Error interrupted it, so let me run that again. This time with a max length of 100. I've sent it this thing. So the large language model should hopefully be able to interpret, this is just some syntax the user has put in, and they're called the user, and then that's the question. In fact, if I print it, it'll come up nicer than that. Because it'll format those /ns. Might look better. I should do that. While that's thinking, I can write more code, print prompt 1, because I want to see the nice formatting. Okay, yeah, that's actually what it kind of looks like. All right, cool. So the response is, what year did this happen? The start of Titanic won the Academy Award for Best Picture in 1953. Very good. So we need to capture this response and stick it back into our conversation history. Okay, so to do that, we now want to do conversation history dot append, and this time we're going to do role model response. Yeah, like so that was good. I just pressed tab and it kind of figured out everything that I wanted to do. So I want to do exactly this again, but I'm going to keep appending to this this history, and I'm also going to just put this command in called strip, and let me just show that what that looks like. So this is printing the response. It looks like that. If I do print response strip, okay, it doesn't look too different, but sometimes like there's lots of trailing like space and everything, so it just cleans it up a little bit. Yeah, because that's just text, remember, that's all it is. Okay, cool. So there's our conversation history. If we can look at the conversation history, it looks like it's a list, so which contains a dictionary of role user, and then it contains another role model, and then it's got the model information there, and then we can do we can then get a second prompt. So the second question could be what other awards did it win? And so I'm going to again just copy this. Okay, role user, and then what other awards did it win? What other awards did it win? So I'm role user, what other awards did it win? And now I have another, I can look at the conversation history again. And so I have another dictionary there with the role of the user and the content. What other awards did it win? Fantastic. Okay, we'll get there. I know there's a lot of moving parts to this, but it's all the things we've kind of seen, just sort of building up to it. And if you take your time and go back and sort of read through this slowly, hopefully you can sort of understand the logic here once it's all sort of laid out. Okay, but now we have a conversation history, and we'll pass that whole conversation history now to our LLM. So once again, where's this? Let's do the same thing. Oh, sorry, and I need to convert our conversation history to with our function, don't I? So I need to go prompt2 equals format. There we go. And so now we'll have this formatted prompt. So it turned it from a list of dictionaries into our basically our prompt. Let me print it so it looks nice. Print prompt2. So this is what it looks like to the large language model. Start of turn. User, what year did the Titanic win? End of turn. Start of turn for the model. And there's no question there. It should be able to figure this out, even though I think there's mistakes in this. This is partially due to the response, where the response of the model gave back the first question, but that's okay because it just kind of repeats itself there. And so then the model finally answers here, end of term, and then the user, what other awards did it win? Model, and then it's waiting for the model to answer. So let's do it. I know this is all very exciting. So response 2 equals Gemma dot generate prompt to max length equals 100. Print response 2. Cool. Any questions? Yeah. Okay. Cool. Yeah. So you got a different answer. Absolutely. Yeah. They will be they'll be different. So in large language models, under the hood, some websites like Anthropic, they let you actually tune the parameters, and if you have sort of deeper access in just the conversation window, you can tune the parameters. So there's something called a temperature and a top P, and so they will modify like how crazy the model is, like how much variation there is in it. that can, and I guess having access to Python, you can modify that as well. You can actually expose. So when it comes up with things, all it's doing is making like a probability distribution of like what the most likely response is, but then it will have like every single option underneath that. So you could take like the 10th most likely response, which could be something completely crazy. But yeah, if you wanted to do that, or you can see what the model is sort of like thinking under the hood. All right, so okay, I might have to increase the max length there. It ran out of context window, so it told me got all the response, but it was cut itself off before the end. You can also do things, instead of just having a max length, you could have like a stop parameter. So the stopping parameter might be like a full stop, or it could be like a new paragraph or something. You can mess with all these sort of things. Okay. And then what time is it? Yeah, cool. So we're making good time. We'll then so this is really good. Like, these local models are fantastic, especially if you have, specific use cases that, or you have like sensitive data that just it cannot like leave your computer, or cannot leave whatever sandbox you're in. So great for that, because at the moment, yeah, this is all done within this notebook. There's no data leakage or anything, as long as you trust this virtual machine that's running. But I don't think anything in Colab like is exposed. Good stuff. So I think some of these might be real. I don't know. Yeah, we're still using the 1B model, so I don't think. There we go. It was truly a remarkable film for the film. You can probably validate that by looking it up. And that's what an agent is. So agents are all of the large language models were the rage in 2024. Agents are the rage in 2025. An agent will basically go and you might have a Wikipedia agent, which then looks up Wikipedia and gets the results from Wikipedia and actually gives the from Wikipedia is fine. It will get the result from Wikipedia and say, oh yeah, no, this is incorrect. So that's when you have a specific use case like that. Anyway, let's so that's local models. Yes, I can step through the cells just as an overview. That's probably a good idea. Okay, so we installed Keras Hub, which is the framework we use for interacting with the model. We didn't have to use Keras Hub. We could use PyTorch. We could use Hugging Face. We could use something called Transformers. We use Keras Hub just for fun. It's pretty simple, and it doesn't necessarily have access to all these underlying features, but it's got enough. Okay, and we use Kaggle Hub to log into Kaggle, so we can just download the model. We then we downloaded the model. We downloaded the 1B model first, Gemma 3_1B, but realized that was just a sort of predictive one, but we wanted a question answering one. So we downloaded Keras 1B, the instruct, the tuned one on instruct. And we can see how we sort of can generate questions and it will give a response, but there's no conversation history. So we wrote a function that will help us build a conversation history. The way the function works is it takes a prompt it takes a list that you pass to it that contains a dictionary. So the list you pass looks like this. Basically contains a dictionary that defines whether a person is a user or a robot, or a user or a model, and the content of the question or the response. And so we pass that to it, and then just formats it nicely in a way that the machine can sort of understand. So it adds these like prefixes: start of turn user, start of turn model. That's all that function actually does. You give it some sort of raw text with some tags on it, and it adds those tags appropriately so the model can look at it nicely. These aren't anything special. We could have probably just had user and a colon, model and a colon, and maybe new lines, and then the model would kind of figure out that that's how it works. But yeah, you can be explicit with that. Okay, and then we send that question to the model with the generate command, and that's basically it. So then we redid it by we just kept adding questions and responses. So I think that bit was a bit confusing, where we're adding more and more. And so when you're in a like a website that's doing this, like Gemini, you are this is what's happening sort of under the hood. So you don't see any of this, but that is actually what's happening. Cool. So now when you want to graduate to sort of bigger models and better models in the cloud, and in fact, it usually works the other way. You'd use cloud models first and then local models. That's what we'll look at next. Let's try and set up our API keys before a break. Sorry, I was Victoria, but I want to. The main reason you do this through Python rather than something like is for one of the big reasons is privacy concerns, but also you have more flexibility. I guess you can do this on 1,000 different models. You can benchmark every single model, OpenAI and Google and Llama and Anthropic. You can use all of them at once. You can have them conversing with each other, so you have a lot more flexibility in Python. And yeah, you can bring your data in, like when you're using the ChatGPT window, like you can only upload like PDFs, pictures, Word docs maybe, and that's it. But in Python, you could upload any type of document and get it into the right format, and then give it to the model. So that's one of the benefits of Python. And you can do it 1 million times. Instead of sitting there typing away, you can generate like code and generate content. So lots of benefits. I could keep going. All right, so let's try, just before we break, we're going to get an API key. So again, if you're using, no matter what service, whether it's Google or Anthropic or OpenAI or whatever, all of them will require an API key. And let's do this. So let's go to this address. I'll go there and then post the link in the chat. Again, if you have a Google account, it should be able to get there. So mine logged in automatically. You may just have to click the login button. And oops, what's happened? Okay, so on this page, yours might pop up straight away saying like, would you like to generate an API key? You can click yes. I have nothing here, so it says create an API key to see your project. This is called Google AI Studio. It's one of like Google's sort of gateways to AI. The other big one is called Vertex AI, which is, can I go there? But I'll just show you because it's fun. Vertex AI. So there's like a lot more buttons, but they are kind of connected. So anything you make in AI Studio also works in oh wait, okay, so to use AI Studio I need to add a card payment. I don't think it costs anything, but I just had to add it, so I won't do that. I'll just stick to AI Studio for now. But yeah, Vertex AI has like 1,000 options and you can do all these crazy things, but AI Studio is probably fine for what we need to do. So up here I'm going to click create API key, and what's going to happen? I can can probably create a project, or I can select one of those. So it's generating an API key. Good stuff. Again, never share this number with anyone, but I can just sort of delete this as I need to. I'll copy it, and that's it. So now I have an API key, and I can go and plug it into our. This one's, I guess, a bit different to Kaggle in that we downloaded a file. This one we just have the single key. So we'll need that in a second. And yeah, so yeah, consent to this. So I'd already done that. Create API key. Click copy. You can always delete it, and we'll use it in a second. So let's just set ourselves up with the client, and then we'll have a break, I think. So you can create a new a new file, or just keep using the same one. I'll just keep using the same one. So I'm going to go from Google, import GenAI. So that's a package made by Google, and we don't want to import the whole Google library. We just want to use one particular Python library called GenAI. So we'll do that, and I think that's it. And then so I'll just run that, make sure that works, and I'm just going to activate my client now, make sure this works. GenAI.client with a capital C, and API underscore key equals, and there's a safer way to do this. Like generally you shouldn't expose your key like I am at the moment. You can put it in the notebook, but if you share that, then obviously anyone who sees it can do it. In the notes there, I have it stored in Google Colab has like a special way to store secret keys, but I won't go through that today. And then there's like you can import it from you can load it from your computer, and there's safer ways to do it, but copying and pasting should be fine for what we're doing. Okay, and so I think that worked. So if that worked for you, have a break. If anyone had any troubles, we'll come back and we'll use this API key to query like a much more powerful model. Okay, any questions or problems? Please let me know. Good stuff. We'll get there in a second. So once again, oops, wrong one. I just went to API keys, and you can create like 1,000 of them. You can just keep creating Gemini API keys. I won't waste it. I haven't set up billing on this account, so I can't use Vertex AI, but that's okay. And you can delete it and recreate it as needed. All right, maybe I'll just, no, that's fine. Okay, cool. That's the right. All right, see you in 10 minutes. Alrighty, we'll get stuck back in. I just posted a link in the chat to this site, realpython.com. It's got some fun little like quizzes and stuff on there. Like obviously we're not doing anything too in depth today, but in there are some questions that can open your mind to sort of the different parts of Python. And a lot of this is sort of like programmer focus, computer science focus. We're very much at the high level, just how does this work? What do we do? But there's some questions there. In Python, you can use underscores to make large integers literals more readable. Write a Python statement that assigns the value 1 million to a variable named large number. So I think the answer might look something like this. I should have attempted this before I had a look at 1 million. So you can do things like, oops, 0, 0, 0, 0, 0, 0. Is that it? There we go, cool. So yeah, you can write things like that. You can write integers with these underscores just to make it more readable. It's fun little things and quirks of the language. But anyway, you can play around with that if you want to have a look around. I won't dwell too much into it just at the moment. We have an API to call. So yeah, coming back before the break, we hopefully all set up our Google AI Studio API key, where we're going to interrogate some of the models they have on offer there. So just going back to the AI Studio, the where you can look at the usage. So this is, I guess, my usage for this account. How many tokens? So everything's done by tokens. I haven't explained what a token is. Basically, a token is like a word, approximately a word, or it could be a couple of words, like a sentence. And there's so many tokens that models can read and write, and you provide input tokens. So that's the prompt that you give a LLM and the tokens that come back. And that's how they calculate the cost for all these kinds of things. The billing should be 0. Haven't set up billing. And yeah, you can play around in here and actually just do everything we're doing now in the studio. I mentioned there's like, you can pick the model that you want to use. There's a bunch of models. You can adjust the temperature. So that's what I was talking about, the craziness of the model, how wild and varied the responses will be. And yeah, there's a few other options you can run. Now, I was looking for the documentation. Everything I've said today is, in the documentation. All the syntax and everything is all there. So we're going to set this up. So our documentation, so our model uses that. But I wanted to get the list of models. Here we go, all models. So we need to load basically in one of these models. They all have different sort of rates. Like you can't just slam it all day long, especially on the free tier. Yeah, there's an ample free usage amount though, but they have like limits. So you can only do 1,000 tokens per whatever. Oh yeah, there's the rate limits. So yeah, 10 tokens per minute, 250,000 tokens per minute, or is that per month? That must be per month. And rates per minute, 10 per minute. I think. Anyway, there's a bunch of models, and they all have slightly, some are newer, some are older, some are more capable, some are better at answering questions, some can do images and so on. And again, this is the sort of the Gemini ecosystem in Google, but it's just the same if you go to any other model platform. Okay, so we have imported a library from Google, import Gen AI, and this just helps us interact with the Google's generative AI ecosystem easily. This is the framework for that. There's the package, which exposes functions, which makes it easy, so we can just type generate instead of having to set up like all these weird structures of conversations and everything, as we will see. All right, and then we've instantiated, that's the word there, our client. Our client is hopefully, I think mine is still connected. Client is sitting there waiting to go, kind of connected to the Google API. And from here, we can start typing some stuff in, but we will get there. We're going to load in an example data set into a pandas data frame and just explore that data frame a little bit, and then just ask the LLM some questions about the data frame. So this is kind of a side into exploratory data analysis, and then how we might set up the prompt to ask questions of the LLM. So that's the goal in the next, for this last sort of section of the course today. Hopefully shouldn't take too long. So where are we? So I've got my client there. Now over here in the side, whenever you use Colab, it comes with just some sample data. So I was just going to use this. Colab, I guess, was designed for machine learning and stuff as well out of the box. So they have these kind of famous data sets, and the one we're going to be using is the California housing data set. And again, going into that machine learning side of AI, it comes in two formats: a test and a train set. So basically, it's just a CSV of a bunch of variables, which we can have a look at in a second. And the testing set has like all these variables about housing, the location, the number of bedrooms, the population, and so on. And then the testing set has, the training set also has the price that the house sold for. But in the testing set, I guess it may be missing what the house price sold for. So you would build models in order to predict, if it can measure all these features, what is the predicted price sale going to be. But we won't go into that in too much detail. So anyway, we're going to read this in. Again, a bunch of different ways to sort of read it from here. You can also connect to your Google Drive and upload documents, and you can just drag and drop your own CSV. So, but we're going to use pandas. So import pandas. I think we should already have it here. It's pd.read CSV, lowercase CSV, and it should be in the folder sample_data/California_housing_train.csv. And I forgot to assign it to a variable. df equals that. Okay, good stuff. I can have a look at that data frame. I think it's huge. So yeah, so that's the data frame. Latitude, longitude, housing, median age, income, house value. It's got all these features. There's 19,000 rows and 9 columns. That would burn through our tokens pretty quickly. So I'm just going to take a subset of this to begin with, just for demonstration purposes. df short equals df.drop, and then I'm going to drop these columns. Equals, let's go housing underscore median age. So this is a neat feature of pandas. So you can say, use my data frame. I want to use the drop method on the columns with these names: total rooms, total bedrooms. And again, there's a bunch of different ways to like subset the data, but this is just the way that I guess I decided to do it. And what was the last one? Household. Make sure I get the commas in the right place. Households is the name of it. Yeah, that one. And also I'm going to say, just give me the top, we can take the top 5 items and df short. Cool. So our new data frame is much, much smaller, but it'll just sort of be easier to kind of comprehend this. So we have longitude, latitude, a median income, and a median house value. So we just have 4 variables. This one looks like kind of like a target. They're sort of just spatial coordinates, which may be related to how much a house sells for, and the median income, which may be someone's median income. Generally, you might expect that to be related to how much their house cost. All right. So any questions? Everyone good? Comfortable? Good stuff. So again, we can do the same thing. df shape. Oh, sorry, df short. We want to use, not df. Otherwise, like I said, I'll burn through my token. So it's only 5 by 4 instead of 17,000 by 9. df short. Actually, I'll use this one for the EDA. Dot describe. So yeah, you can once again just talking about pandas and some exploratory data analysis. You can check, if there's any null values in there. So is there any missing data? Oh, that's that's just printing out the whole data set and saying false, 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 false. So they're all good, but we can just do something like sum, and that will say, okay, they're all zeros. So that's good. There's no missing data. Especially in machine learning, you always have to deal with your missing data in some way, whether it's ignoring it or taking an estimate or some median or mean. Okay, and we haven't spoken about plotting today. So plotting in Python, there's a bunch of different ways to do it. Most of it is built on a package called matplotlib. But the Pandas has like some plotting functionality built into it, and you can just do like a scatter plot. Scatter x equals, let's say, the median income, and y equals the median house value. Okay, and let's have a look at that. There we go. So there's I can adjust the plot as well. I can do the size of the dots is 1, so S for size, and I can make them slightly invisible with an alpha of 0.5, so increase the transparency, so it might make it a little bit more readable. So yeah, I mean, just to your human deep learning system here, your neural network, you can probably see there's some kind of trend there between the median house value and the median income, and then it caps out at some maximum house value. So it's probably the data set only went to like greater than 500,000 or something. So there you go. That's my neural network working. We'll see if we can get the LLM to sort of ask these same questions. You can do some other neat little things, like there's a bunch of sort of out of the box exploratory data analysis that you can do. So I'm just going to import another package called Seaborn, which is a good data visualization package, and I can do hist plot df median house value. Let's go kernel density estimate. Is that what it stands for? KDE equals true, and give you some like beautiful plots about like, yeah, what the actual distribution looks like. Yeah, you can see that capped out 500,000 there. And I think in the notes I've got the heat map is heat map. And you want to do a correlation core. I think that'll just work. If I just do that, you can make it, you can add some more details to it. Let's change the color map. Color map equals cool to warm. Yeah, you can sort of see how variables are correlated together. So just a little bit of stats and EDA there. Now, if we want to ask questions about this data, so the thing with the LLMs is that generally they only understand like text data, unless a model has been specifically trained on a type of data like JPEGs or PNG files or PDFs. And even then, it's usually like translating that into some like machine readable format. They have to be in text. So we have to, so at the moment this is like a data frame, but we have to turn this into something that that we can pass to the LLM and ask a question of it. So keep that in mind whenever you're, working with large language models. Everything comes down to like text, and it's like a string of just a stream of consciousness that it has to interpret. So I'm going to create a new value. So even if you've kind of missed all that EDA, nothing's too important except the little bit where we drop the columns. So you can just copy this first cell from the notes, the import pandas, reading in the data and dropping the columns, and you get this df short value. Okay, and now going back to my notebook, sorry, I'm jumping around a little bit. I'm going to say df string equals df short, and use the pandas method to _string and df underscore string, because we're going to have to put name df string is not defined because I use a capital S. Let me do that again. Okay, so it's just a string of numbers now. So this is something we can give to the prompt when we pass a question to the large language model. And our prompt might look something like this. So prompt equals, let's do an F string with multi-line comment. It says, hello, I have the following experimental data. And then we can say df underscore string. Please answer the following questions about the data. Okay, so that's going to set us up. So that's our prompt that we're going to pass to the LLM. So I can, when we print that out, you know, it looks like a nicely formatted text output, but we need to combine that with like now some questions and pass it. And so let's do that. Let's set a question equals, where are these data located? Okay, I think that's and so our full prompt is going to equal the prompt plus the question, plus question 1. Okay, so I'll just print that out for full transparency, full prompt. Okay, so there we go. That's what we're going to pass to the LLM. You could add multiple questions there, which we can do. So well, let's start with that one. And here's the syntax that we need to work with Gemma. And it's already telling me like, oh, that's using my Gemma value, but we want to use something else. So that prediction is incorrect there. I'm going to use my client that I made before. So that's all the way back up here where we connected to here. And I'm basically just following the documentation. Where was it? Here, overview or quick start. Yeah, this thing. I'm just going to do this. Response, client models, generate context. And then it's going to give me an answer. Where am I? Okay. So client dot models dot generate content with a lowercase, keep doing content. And then the model, this is where we specify what model we want. In our case, I think in the notes, I've just used Gemini 2.0-Flash. That's a pretty powerful model. And then the content that we're passing it, contents, is going to be this full prompt. Sorry, this is get out of my way. Okay, full prompt. And I think that's it. And then I'll print the response out. Response, I'll print the whole response, and you'll see like, in this case, it returns like a bunch of stuff. So it returns information about the model, or returns a prompt, it returns a token count, although it says none. There's a lot of like information you get back. Oh yeah, there's the token count 195. So all we want though is response.text. So unlike the Keras Hub framework, when we got a response, it just returned the text. We could probably ask it to return more things. When the default response from our AI Studio using our client is like I think it's probably a dictionary or something, or it's a list. So it's a list of various things. But there's the response we got. So let me print that. And I think it did a much better job than what our local model would have done. It's probably in Southern California. Here's why, and it explains why. You know, that's approximately the Southern California location. Without additional context, could be difficult. However, the provided coordinates strongly suggest a region in Southern California. So there we go. There's, you know, so you can get some information from your data. Now, I think then what else do I have in the notes? I've just got another prompt there in the example, which is I'll just copy and paste this one. Why not? You think of some other interesting queries you could pass it. This is what do median income, median house value represent in this data set, and what insights can you draw from their relationship? So let's see what it says. It's thinking, printed the question, and then here's my, okay, let's analyze the provided data snippet. So this is more like, probably more like the language models you're familiar working with. This column likely represents the median income. But if your university or institution has some local API as well, you can plug into those safely with your data. Okay, and it even says, that there's not many rows. It's difficult to draw conclusions from 5 rows, but we can observe a few things. There's a positive correlation between median income and median house value. And there's a limited range. The range is quite narrow in the sample. To draw definitive insights, you would need more data. So there we go. So that's basically all there is to it. Now, we're using the Gen AI package to query our data set. If you use any other LLMs, you probably come across the OpenAI like syntax, which is just slightly different. So you can see here, we still set up our client the same, but then use this command chat.completions create, and you have to pass it the role and the system and the content. So I think the Google framework sort of does that for you. So it strips away all that requirement, and you just pass it the question and it will deal with it. But OpenAI was one of the first ones. So they kind of have a bulk share, and most APIs are compatible with the OpenAI one. So keep that in mind. And so I think that's basically like everything I wanted to cover today. Are there any questions? Okay, ask away, Victoria.
Does my microphone work? Can you guys hear me?
Yes.
Yeah. Okay. This is sort of a general, more of a Python question, because I haven't used Python before. Is there any disadvantage to doing Python in this Colab? Because it seems really good and really like user friendly and stuff. So I'd be keen to, use it. But is there any times where it's like not suitable?
I think the main time it's not suitable if you've got some funky package dependency problem. So if you're using some really weird packages, Colab comes with a whole bunch of packages pre-installed, and they're relatively like modern. But if you're using like really old ones or something, then it'll be really hard to sort of get it working. So that's probably the main and only time I wouldn't use this, or if you're not allowed to upload your data or something. But otherwise, it's very powerful, and I use it most of the time actually. So
okay, cool, thank you.
Yeah. So prompt engineering is kind of different. So the question is, what we did say is that prompt engineering. So prompt engineering is, instead of saying something like, I have the following experimental data, please answer the following questions about data. We've just engineered a prompt. So like prompt engineering is modifying this to kind of like get in tune with the model. So I could just say like, here is some data, and I could then say like, where are these data? And so this is probably not it's probably not as good as a prompt. And let's see what the response is. So this is prompt engineering, where you change, my thing crash, df string is not defined. Oh, sorry, I'm in the wrong notebook. Sorry, let me go back this. So here is some data. Here is some data. And then what did I say? Where are these data? I'll just make it like not as well constructed, the prompt. And then I'll run it and see, hide that. Okay, you can see it's much quicker than running locally. Okay, so it did a pretty good job. Like it still gave us an answer. It was, in fact, it did a great job. We could even ask, like, maybe get rid of the data prefix and just say, you know, just give it the data blankly, and then ask again, and you'll expect probably like a worse response, or maybe it's still pretty good. The data you provided appears to be a snippet from a data set. It's actually giving us more information because it's thinking. So like I said, these models are pretty good. Like these modern models are like Gemini's, you know, fantastic, and it kind of can understand a lot. So prompt engineering, I feel, is almost becoming less required. You can still do the where you give it a specific task and say, you know, you are a data analyst. You must like interpret the following data as if you were a real estate agent or something, and you want to make sales. So we could say that. Let's do that. You are a real estate agent, and then here are some data, and then let's see if we get a different answer now that it thinks it's a real estate agent. Does it do anything? No, it didn't do anything different, but it might, like it might say like, oh, a great place to sell places instead. But that's basically prompt engineering, just modifying your prompts to get like, try and massage the best results out of it. Yeah, okay, second part we did just now was using Gemini based online summary. Yes, we download them to Google Drive. If so, is there, yes, so the advantage of using the Gemini models in hosted somewhere is that they, like, you can get a much more powerful model. Like it's running on like Google data centers on their TPUs and GPUs there. Whereas local models, you're kind of restricted by whatever hardware you have. Like these models, they take a lot of computing power to run. That's why we used really basic models when we were doing the local one. They were using just the CPU, and they were quite slow. Remember, they took like a minute to run each time. Whereas this, we pass it like a question and it gives us like a really powerful answer. So that's the benefit. But then obviously, like just data sovereignty and everything is the concern, and whether your data is allowed to be sent over the internet. Yeah, any other questions? So yeah, real basic sort of introduction to Python. Hopefully you kind of can see the oops, what did I just do? Hopefully you can see sort of the power of Python and what kind of like options there are, the sort of syntax that's around that's possible with it. I've got just one thing to ask. Here we go. I have a survey. If everyone could fill out this survey real quick while I give a debrief. So the survey's very short. There's something 4 questions. Just tell me one thing that went well today, and one thing that could have been improved, and if there's any workshops that you or your colleagues or anything may be interested in. So our AI for Science community, you know, we're always looking to provide things that are useful to researchers around Australia. So if there's anything in particular that you really want to know about, please write it down, and we'll see what we can do. And then any other feedback as well would be great, and we'll always seek to improve this. So this is the first time we've run this. Yeah, I've sort of been making mental feedback as we go, but anything you want to add? Yeah, so we covered like the Python fundamentals. You know, just sort of knowing that this language exists, the syntax, the types that's possible with Python. Every other language is kind of the same. It's just slightly different. Once you know enough, you can ask the questions in Gemini and say like, oh yeah, write me some code that, you know, makes a plot with this type of data, and it will just do it for you. And that's a great starting point. But the being able to be like, oh yeah, I know that I now want to make it like green, like the plot green or something. You know, you can just add a variable and go from there. I didn't dwell too much on documentation, but the documentation of NumPy and these large language model packages, Gemini and everything, it's really comprehensive, and I spend my life reading it. It's really good. So any questions you have are in there. Obviously, asking questions with Gemini is an easy way to do things. Yeah, you've seen sort of data structures and control statements, flow, if, else, and for, and while. So these are all concepts which help understand the logic that are required. Some people are worried that, with coding capabilities of AI, that there's no use to learning a programming language. I think it's still really useful. You need to guide it. I find myself like coding less now, but I have to guide the LLM appropriately. So which is fun, and then I take over. So yeah, and I didn't dwell on the machine learning side of things, but that's a whole other sort of aspect to AI and everything, and computer vision. But write down anything in the feedback forms that you have, and otherwise, thank you very much, and we'll see you next time. I think our next workshop is actually next week. We're doing just a JAX talk, so that's more of a talk. And we've got a couple of JAX events coming up, so be sure to sign up for that. All right, so thank you very much, everyone, and speak to you soon.
Thank you.
Cheers.